Now I have active stack fingerprinting, and there's also passive fingerprinting. With active stack fingerprinting, it's based on the fact that most vendors, or I should say different vendors, have different TCP stacks implemented. So by looking at their TCP stack, I can hopefully determine what kind of OS it is. And what I do is I can send specially crafted packets to this remote operating system, and then I can compare the results I get back with some results I have stored in my tools to find out what your OS is. Some of the things I can use for this kind of fingerprinting would be Telnet. I can simply send a Telnet packet, and then once I have a Telnet, I'll send it to port 80. Now you notice normally port 80 is reserved for HTTP. But by sending a Telnet command over port 80, I can actually send what looks to be like an HTTP header. Now of course I won't get the connection, but what will happen is it'll go ahead and send me back an error message and tell me that no, you can't have this. Well, once I have that error message, now I can normally determine what OS is running on that machine. Some other tools I can use are Xprobe 2. This is another remote OS detection tool, and this one determines what OS is running with very little interruption to the target itself. I also have Ring V2. Now this one does a little bit different approach. What it does is it tries to identify the OS with a matrix-based approach. In other words, it tries to go ahead and get all of the results back and then compare them to its internal database. Now most of these tools, the Nmap and the other tools, are used for what's called the active fingerprinting. Now passive fingerprinting is another matter. Passive fingerprinting is basically whenever I do something like banner grabbing, I indirectly scan the system and I have it tell me what is its operating system. It's a little bit different, and it uses different sniffing techniques instead of actual scanning techniques. Now it's not going to be as accurate as active fingerprinting, but passive fingerprinting can still be helpful nonetheless. Some of the tools that I can use, for instance, is Netcraft. Now Netcraft is a website. You basically browse out to Netcraft and you can use that to identify the remote OS of that target system. Vulnerability scanning. Now that I know what OS you have, now I want to look for what vulnerabilities you have. So I can use different tools. For instance, Saint is a very popular one. It's really called Security Administrator's Integrated Network Tool. And basically what it does is through a 4-step process, it will scan the network, look for anything on the target, and then try to tell me exactly what OS it's running and what ports are open. I could also use a tool such as ISS Security Scanner. And what this does is provides an automated approach to detecting what the OS is and what vulnerabilities are there. Nessus is also very popular. It is definitely a vulnerability scanner, and what it does is looks for different bugs in the software. So basically an attacker can take this tool and use this to actually violate your security of the different software pieces. In other words, at the different application layers. Some of the features is it does have a plug-in architecture, and there are new plugins available all the time. It has its own scripting language. You can test an unlimited number of hosts at the same time. It does have smart service recognition, and it does have a client-server architecture. So Nessus is a very good tool for detecting vulnerabilities. And you can see there are Windows versions of Nessus as well as Unix or Linux-based versions of Nessus. Now another tool that's meant to be a network tool is called GFI LAN Guard, and what it's supposed to do is analyze the OS and tell me what applications are running and look for the different security holes. Well, of course, this is a tool that can be used for good purposes, but quite often it's used by people for bad purposes, because what it does is scan the entire network, going IP address by IP address, looking on every machine for what is running on what port, and then whether or not the security patches have been applied. A lot of times, remember, you don't have to have a particular machine, or maybe you can't get into a particular machine because it's been patched, but all it takes is one weak machine on the network, and this is one tool that you can use to find that one weak machine on the network. Some of the features, it's very fast. It does fast TCP and UDP port scanning. It'll find all shares on the target network. It'll pinpoint where the security problems are, and it will automatically detect new security holes. It checks your password policy if there's one in place. It finds out all the services that are running on the target network, and it does have a vulnerabilities database that includes Unix and CGI issues as well. Another tool that gets a lot of use is Satan, Security Administrator's tool for analyzing networks. Now, it is a security auditing tool, and it is supposed to examine Unix-based system and report the vulnerabilities. It provides information about the software, about the hardware, and the network topology. It has a very user-friendly program, and it basically works in an X window. It is written in C and Perl, and to run Satan, you're going to have at least Perl 5 and a C compiler installed on the system that you're launching it from. In addition, the attacker needs a Unix-based operating system, and it has to have at least 20 megs of free disk space on the system. Retina is also a vulnerability scanner, and what it does is basically, again, scan every machine on the target network, including a bunch of different operating systems, network devices, databases, and third-party or even custom applications. It has by far the most comprehensive and up-to-date vulnerability database and scanning technology. Another one is NIC2. Now, NIC2 is an open-source web server scanner. What it does, perform comprehensive tests against web servers for multiple items. It tests web servers in the shortest time possible. It uses RFP's LibWhisker as the base for all network functionality, and for easy updates, the main scan database is in a comma-separated value format. It does support SSL, and you can put the output into a simple text file, into HTML, or you can also put it in CSV format. Again, this one does have plug-in support, and you can have generic or server-type specific checks as well. Continuing on, SafeSuite Internet Scanner and ident TCP scan. First, SafeSuite. Now, SafeSuite Internet Scanner was developed by ISS, and basically it was supposed to analyze vulnerabilities of Windows NT networks. So it is intended for NT 3.5.1 or 4, and you do have to have a key for it. But what it will do is report all possible security gaps on the targeting system. It will also suggest what kind of corrections you could make, and it uses 3 separate scanners: an intranet scanner, a firewall scanner, and a web scanner. Now, ident TCP scan examines the open ports on the target host and reports the services that are running on those ports. A special feature that uses the UIDs of the services to help identify, in other words, to ident those particular services. So we have scanned the network. We've determined what live hosts are there. We've also done some OS fingerprinting, and now we've done some vulnerability checks on those OSs. The next thing we need to do is we need to map out our target network. One of the many tools that you can use for this is CheOps. CheOps can be used for OS detection, and in fact, it's used quite often for that, and it will automatically generate a map or a diagram of the network to find out exactly what's running on it. Another tool that you could use is Friendly Pinger. Now, this is more of a Windows application, but again, it's very powerful, and it lets you create all kinds of custom devices or custom maps based upon the information that you've determined.